მოგესალმებით.
Kobiashvili from the Civil Registry IT Infrastructure Service, head of this service. A cheap data center cloud storage for cold data is the topic of our presentation. But before making the presentation, I want to tell you about the National Agency of Public Registry. So we have implemented up to 60 successful IT projects. First of all, it was the property registration, business registration, document flow system, address registration, notary software. So we have implemented more than 60 computer applications. Especially important is the real estate and business registration. Doing business rating grants us #1 rating in the world. And in property registration, well, we are on the 5th place in terms of the business registration. In addition, we have implemented the electronic procurement system that was launched in 2010 and saved to the government 788 million lari, and in 2012 was regarded by UN as one of the best solutions to fight corruption. So we have the maps, the neighbor government infrastructure. The public registry plays the main role in this project because this public registry is the owner of the majority of information systems. Of course, these projects require solid infrastructure, and of course the data are increasing permanently. With this regard, last year we started reorganizing infrastructure. We introduced a cloud system, Openstack. Today, Openstack has become a de facto standard for building cloud. There is no IT company that does not participate in this Openstack development or sell commercial projects. Openstack gave us the opportunity to manage the entire data center and additional equipment. Most importantly, in our data center, we have today both the vertical and horizontal scalability models. There are tasks that can be scaled only vertically or only horizontally. The difference is that in case of vertical scalability, the task is easier. It is sufficient to purchase the more powerful equipment, while in case of horizontal scaling, the similar capacity equipment is okay, but technologically it is more difficult, but is cheaper. So we have taken this decision in order to have the infrastructure actually adapted to any type of tasks. OpenStack actually manages this infrastructure completely. The main components we have is the calculation research network, resource and the reserve system, storing system. I'll speak about the storing system. I want to especially underline, and those who work in infrastructure knows that the storage system is one of the major components and the critical components and most expensive components of any system. In IT information, it is more important because here the valuable is information and not technology. And technology is simply an instrument, and we need technologies in order to store the information.
And it's diagram, so it's the results of the investigation of this analytical system, IDC, analytical company. It is considered that recently, during the last 2 years, 90% of the information that humankind has created, 90% of this information was created during the last 2 years. So we can say that this increase of data data is inevitable. It is inevitable, and we a priori know that its decrease of information cannot be expected. And new projects are going to be implemented, and we don't know the volume of this project. And the data that are created in a country, they have some dates, so they are valid during to 10, 15 or 20 years. And electronic data and their storage and processing is easier. And with the passage of time, I think all this data might be stored forever. And the more information, more data we store, so more analysis can be conducted. So the increase of data, so the amount of data will increase in future, only increase. And in order, so in a long-term, storage needs to be reliable. So we need and sustainable and scalable, and so these technologies should be available, and so otherwise we'll go to the dead end. In order to solve these problems, we use the software-defined storage. It's a CF open source resolution. It's a decentralized system, distributed system. It doesn't have any point of failure. It's a horizontally scalable, reproducible, and one object can be recorded in several different places. So any devices might be used for it, personal computers, disks, and why? Because all this protection is a logical one, and is in a software. And self-management, what does it mean? Very often when we record files on the Winchester or on a CD, for example, and forget about it, we are sure and think that these data are protected. But in several years' time, sometimes these data cannot be readable because every type of storage system is a physical device, is a physical equipment, and physical equipment is affected by the environment, and in order to protect the data and in order to make sure that this data are not that don't fail, you have to once in a while to read this data in order to make sure that they are not deleted or in CF system case, system does it itself, and it double checks this information periodically. And if the files have some errors, so these files are re-recorded or are sent to the alternative backup system. So in a long run, or in a long-term perspective, you'll be protected against some errors, or if there errors occurs, the system will record itself. So how should we protect it? It is replication and ISO coding. In the case of replication, one object or file is copied, has 3 different copies and is copied in 3 different servers. So if 2 servers are out of order, the data might be readable from the third service. So it's an approach that enables us to redistribute this reliability to different servers. If it's copied, it can be managed by the administrators, but overhead is very big, and overhead is 200%. In order order to protect one file, so you need 2 additional copies of this file. But there is a alternative, it's eraser coding. It's an error correction, and it's an algorithm of error detection and error correction. It's eraser coding. In this particular case, what do you do? The objects that you record, it is divided into different blocks that can be configured. It is recorded, it is divided into 4 different parts, and each part is stored in different servers, and there are checksums, and these checksums are stored in other servers as well. So in this particular case, we have 4 blocks of data and 2 checksum blocks. So if 2 blocks are lost, so this data might be restored. It doesn't matter whether X or Y disks are lost, or 1, 2, 3, 4 are lost, so they are restorable. Overhead is decreased to 50%, so overhead is 50%, but what is the minus of that? It's very slow. If data are lost, so it recalculates itself, but it's very good for CV data. So for cold data, it is eraser coding. I'd like to talk about if we have CF, we have read-Solomon algorithm, and it's widely used. If we don't have this algorithm, so it will be very bad for us. But CD is restored by the read-Solomon. In QR code, we have read-Solomon. Read-Solomon protects it. Sometimes it happens that some parts are not readable, but due to the read-Solomon, it is readable. In 1970s, read-Solomon has been used from 1970s in airspace and is used in servers. RAID 6 is one of the algorithms of read-Solomon. But what are the restrictions? Sometimes only 2 disks might be lost, but it's not restricted by read-Solomon. So overhead increases in this particular case. What is the result? CEFI is software-defined storage, and it is supported by the eraser holding, and we can have this architecture of the storage system. In the case of REDX, read-Solomon works between disks and within one server. CEF can use between data centers and between different servers as well. So you can see it. For example, we have 10 data centers, and recorded data are redistributed, so are divided into fixed blocks, and so checksums are in one block, and the data are in the first 3 blocks. I didn't know how to draw it, but if the data from the first block are in the first 7 data sets, and the checksums are stored in the last 3 blocks. So the data from the second blocks are redistributed. So these checksums are rotated. I rotated between them, and it enables, this algorithm enables us. If we have 7 and 3, overhead is 43%. It is decreed, and if any three data centers are failed, so the data are readable, and the data center. It's not necessary for the reliability of the data set to be very high. We have the very high reliability of the whole system. And it's not necessary to have the high reliability of any data center. If we don't have the UPS, we might not have the holding system. So the 3 data center don't fail simultaneously. It happens very rarely, and the administrators should find this golden balance. This infrastructure doesn't depend on the equipment. You might use different type of equipment produced by different manufacturers, or you can use even obsolete equipment. In the long run, this open source software solutions will enable us to migrate. For example, 10 years ago, we have 240 megabyte disks, but we'll have 10 terabyte disks, and we should take into account that this equipment will be replaced by so migration is very painful when we have this equipment, but if we have software, if we also have software, data is copied by the software, and it does not depend on the equipment or the hardware. If CEFI is open source, we won't depend on the equipment. We won't depend on the equipment. It might be ARN, or it might be SX86, NIPSI, or some other architecture might be used. Everything that might be bought. It doesn't depend on the operational system, and nobody requests licenses for updates. This system, HiTORS, has already been used, and it has been widely used more than a year. And in order to implement this idea, we need more and more people, because we have only 2 data centers, and in order to have this decentralized storage system, we need more participants, more people. The more participants, the reliability higher, the storage volume is higher, and overhead will decrease, and the cost will decrease. And so when the cost is decreased, it means that we don't depend on the licenses. We may use any type of equipment, and the more organizations, agencies are used, the overhead decreases, and the quality and the reliability rate increases. And why do we think that it might be realized easily? Because many governmental organizations have established data centers, different volume data centers, and many of them increased it. Some infrastructures remained there. From the one point of view, it might not be used, but this idea and this infrastructure enables us to use any type of infrastructure that has already been used, and any type of equipment that have been used, and will be more independent. So it means that we might use older data centers and existing data centers, obsolete equipment, state-of-the-art equipment. We won't depend on any vendor, on the licenses. The system will be decentralized, and if the 3 data centers are off or fail, so the data will be readable anyway, and but it happens very rarely when the 3 data centers are cut off, and it is very difficult to intentionally organize the failure of 3 different data centers. And preceding from the title of my presentation, I can say that this system is used for cold data. So it's impossible to have hot data in this data system. That's the end of my presentation. If you have any questions, so I'll be very glad to answer them. Only 1 minute. So we are behind the schedule, so only one. Ladies and gentlemen, Mr. Irakli Gwenetadze, who made a presentation today in the morning. I took part in this debate and I presented my book to him. It's not his personal present. I presented it to the cybersecurity and cybersecurity event of Georgia. So it's a present, not only, it's not his personal present from me, but to the whole conference, to all of you, to members of the panel, to all the participants. I am Lieutenant General here, and my photo is an old one when I was a colonel. Now I'm Lieutenant General, and my new photo is here. So I'd like to present this book to all the participants of the conference. Thank you very much.